all. In previous classes, we have learned about IP security authentication protocol. Now, we are going to discuss about ESP protocol. ESP protocol, encapsulating security payload. First we'll see packet format of ESP protocol. Packet format of ESP protocol. So packet format of packet sizes 32 bits. First field is security parameter index. Security parameters index, and call it as SPI. Okay. Security parameter index is used to identify in a security association. Next field is sequence number. Sequence number. Okay. Payload data. So, actual data to be transmitted. Next field is padding length. Next header. Padding length. Next header. Last field is authentication data. Authentication data. That is optional field. Packet format of ESP protocol. Okay, first one is security parameter index. This is used for identifying security associations. Next is sequence number. Payload data. Payload data is the actual data to be transmitted. Okay. Here ESP protocol, that is implemented in two ways. First one is ESP with optional authentication. Second one is ESP with authentication. ESP protocol is implemented in two ways. ESP with optional authentication. ESP with authentication. Okay, ESP protocol is implemented in two ways. ESP with optional authentication, ESP with authentication. If you are implementing ESP with authentication, this field authentication data, this field will be enabled. Okay, if you are implementing ESP with authentication, this field authentication data will be enabled. If you are implementing ESP without authentication, this field is removed. Okay, that is authentication data. Next, this one is padding field. Padding length, next header. Okay. ESP is mainly used for achieving confidentiality. For achieving confidentiality, different cryptographic algorithms are used. For example, DES, AES, RSA, IDEA, etc. Different cryptographic algorithms are used for achieving confidentiality. Okay, for taking any of these algorithms, the plain text is processed in number of blocks. ഏതൊരു cryptographic algorithm എടുക്കുകയാണെങ്കിലും plain text process ചെയ്യുക. number of blocks വെച്ചിട്ട് blocks ആയിട്ടാണ് plain text process ചെയ്യുക. Okay, for example, if you are taking DS algorithm, the block size of DS algorithm is 64 bits. Okay, the plain text is less than 64. We have to append. We have to add some more dummy bits so that the length will be equal to 64 or multiple of 64. Okay. DS ന്റെ കേസിലാണെങ്കിൽ DS ന്റെ ബ്ലോക്ക് സൈസ് എന്ന് പറയുന്നത് 64 ബിറ്റ്സ് ആണ്. Okay. If the plain text is less than 64 bits, plain text എന്ന് പറയുന്നത് 64 ബിറ്റിനെക്കാളും കുറവാണെങ്കിൽ we have to append some more bits. ഇതിനാ കുറച്ച് ബിറ്റ്സ് നമ്മൾ എക്സ്ട്രാ append ചെയ്ത് കൊടുക്കും so that the length will be equal to 64 or multiple of 64. If the length is less than 65, that is length, plain text length is 63, we have to append more bits, more extra bits, then the length will be equal to 64. For this, padding field is used. To achieve confidentiality, padding field is used. This padding field, this field allows block oriented encryption format. This field, padding field, allows block oriented encryption. Block oriented encryption. Block oriented encryption. Okay, next we'll see different modes. Transport mode and tunnel mode. First, we'll see about packet format. Packet format of IPv4 and IPv6. നമുക്ക് IPv4 ന്റെ IPv6 ന്റെ പാക്കറ്റ് ഫോർമാറ്റ് ഫസ്റ്റ് നോക്കാം. ഇതാ IPv4 ന്റെ പാക്കറ്റ് ഫോർമാറ്റിൽ ഫസ്റ്റ് വരുന്നത് ഒറിജിനൽ IP ഹെഡർ, original IP header, TCP data. It's the packet format of IPv4. Okay, next packet format of IPv6, original IP header, extension header, TCP data. This is the packet format of IPv6. Okay, then after applying ESP, the packet format will be like this. Okay. Original IP header, ESP header, TCP data, ESP trailer, ESP authentication. After applying ESP, then we'll get packet format of IPv4 like this. Okay, here have to include ESP header, ESP trailer, ESP authentication. Okay, this is the case of transport mode. Okay, next IP version 6. Here also this data will be in encrypted format. Okay, this data will be in encrypted format. Encrypted. Next we will see IP version 6 in transport mode. The format is like this. original IP header, extension header, ESP header, TCP, data, ESP trailer, ESP authentication. Okay, this is the packet format of IP basics after applying ESP protocol. Okay, here also this data will be in encrypted form. Okay, this data will be in encrypted form. Okay, this is the case of transport mode. Next, we'll see tunnel mode. Case of tunnel mode, the complete packet will be taken as inner packet, then add new IP header, then send. Okay. So, IP version 4 packet format. Case of tunnel mode, after applying ESP, have to include ESP header, and new IP header, ESP trailer, then ESP authentication. Okay, here inner packet will be encrypted. Okay, this packet ആണെങ്കിൽ ഇത് ഒരു inner packet, full packet, inner packet ആയിട്ട് consider ചെയ്യും. Then have to add new IP header. Okay, here this data will be encrypted form. Here this data will be encrypted form in the case of tunnel mode. Next is IP version 4 packet format after applying ESP protocol. The case of tunnel mode. Next we'll see IP version 6 packet format after applying ESP protocol in tunnel mode. Okay, here new IP header, extension header, ESP header, original IP header, extension header, TCP, data, then ESP trailer, ESP authentication. Okay, it's the IP version 6 packet format after applying ESP, the case of tunnel mode. Okay, here new IP header, the inner packet, whole packet will be taken as inner packet, then extra new IP header will be added. Okay, here this data will be encrypted format. Data will be in encrypted format. will be in encrypted format. So all about ESP protocol. ESP will be implemented in two ways: ESP with authentication and ESP without authentication. Okay. Here, if you are implementing ESP with authentication field, authentication data will be enabled. Otherwise, it will be removed. Okay. Padding field allows block oriented encryption. Next, the packet format of IP version 6 and IP version 4 in the case of transport mode and tunnel mode after applying ESP protocol. So all about ESP protocol. Okay. Next is key management. Key management in IP security. Okay, key management of IP security involves determination and distribution of secret keys. Determination and distribution of secret keys. IP security supports two types of key management. First one is IP security supports two types of key management. First one is manual and automated. Manual and automated. Okay. In case of manual, system admin manually configure the system, each system with its own keys and with other communicating systems. System admin തന്നെ manually system configure ചെയ്യും. അതിനു വേണ്ടി യൂസ് ചെയ്യുന്ന കീസ് എല്ലാം അസൈൻ ചെയ്യുന്നു. അതെല്ലാം സിസ്റ്റം അഡ്മിൻ തന്നെ ചെയ്യുന്നു. Okay, system admin manually configure each system with its own keys and with other communicating systems. Okay, in the case of automated, system enables on-demand creation of keys for security associations. On-demand creation of keys in the case of automated. Okay, manual is practical only for small static environments. In the case of automated, it is practical for large distributed systems. Large സിസ്റ്റത്തിൻ്റെ കേസിലാണെങ്കിൽ ഓട്ടോമാറ്റഡ് കീ മാനേജ്മെൻ്റ് ആണ് യൂസ് ചെയ്യുന്നത്. സ്മോൾ സിസ്റ്റത്തിൻ്റെ കേസിൽ, സ്മോൾ സ്റ്റാറ്റിക് സിസ്റ്റത്തിൻ്റെ കേസിലാണെങ്കിൽ മാനുവൽ കീ മാനേജ്മെൻ്റ് ആണ് യൂസ് ചെയ്യുന്നത്. ഓക്കെ, ഇൻ ദിസ് two protocols are used for key management. First one is key management protocol. Key management protocol. Next is Internet Security Association Key Management Protocol. Internet Security Association Key Management Protocol. Okay, Key Management Protocol and Internet Security Association Key Management Protocol. First one is Oakley Key Management Protocol. So, Key Exchange Protocol or Key Determination Protocols, it is based on Diffie-Hellman Key Exchange, but providing extra added security. Okay, Oakley Key Management Protocol is a refinement of Diffie-Hellman Key Exchange. Okay, but extra security will be added. This is generic, means does not provide specific format. So generic protocol does not provide specific format. Next one is ISA-KMP, Internet Security Association Key Management Protocol, provides framework for Internet key management and provides specific protocol support. Okay, Oakley Key Management is a generic protocol, does not provide specific format. In the case of ISA-KMP, Internet Security Association Key Management Protocol, it provides specific protocol support and provides framework for Internet key management. Okay, it's all about key management and IP security. Thank you.